Carla had asked me to start off by saying a few words about what the UGA River Basin Center is, since you all have various water institutes, centers, things, and I'm still trying to figure out what they all are and do. But maybe I'll talk about the RBC a little bit, and that maybe spur some subsequent conversations. So I'll start with that. But let me just first say just thanks to y'all. I've really enjoyed the meetings I've had with folks this morning. It's been really stimulating and fun to be here. It's weird that in all the years I spent in Georgia, I have never been over to Tuscaloosa. So it's fun to actually be here. It's not so scary in person. So, okay, so the River Basin Center, this is just a screenshot of our webpage, homepage taken this morning, and that says our overall mission there, connecting freshwater science to management and policy. Centers at UGA mostly are kind of virtual. We don't have a budget from the university for operations. Our support is almost entirely from external grants and contracts. And so we exist, to the extent that we exist and do useful things, it's by virtue of having engaged faculty affiliates and student affiliates. We've got 70-some faculty affiliates these days. They're highly diverse, spread across all different units of campus. Our funding is, these days, it's averaging around $5 or $6 million per year in active grants and contracts that our affiliates have. What we do is we're operationalized around this idea of connecting the water science at the University of Georgia to management and policy needs, which are largely brought to us by external partners. We work a lot with federal and state agencies. A lot of our work is in the Southeast, although we also work globally. So our support includes a lot of traditional academic kind of support, funding from NSF, other big research agencies, but we also do a lot with Fish and Wildlife Service, USGS, state funds, Department of Natural Resources, et cetera. Our approach is we are particularly like working on interdisciplinary projects that require engagement from multiple folks with multiple skills and backgrounds. We also do things like hosting the Georgia Water Resources Conference every year and other events. And fundamentally, one of the things, the way I see our mission is, well, my mission as co-director, so we've got two directors, actually. I'm the director of science, and now we have a brand new director of policies at Chindra Valerie. So very excited to have that position filled again. So we say yes to things. So when partners come to us and say, can you help with this? Our answer is yes. Sometimes we're not the best person to help them, in which case we connect them to someone, whoever is. And so partnerships are really important to us in that, and I'd be excited to build more of a partnership with some of the institutions here. Because, we can bring a range of expertise, but there's some, like for example, we were just approached 2 months ago by the National Rivers Commission of Bangladesh, wanting to partner with us to help guide them in cleaning up the rivers around the city of Dhaka. And this is something that I looked around at our expertise and said, I don't think we're the right persons to lead this. But we're going to find the folks who are. And so we're in the process of putting together a coalition of folks, including a number of Bangladeshis who have relevant expertise in that area and also can speak the language, which is important because most of their key documents aren't translated into English. And so one of the barriers we had initially was just those translations. So we're trying to build the team that's going to support them in what they need to do. And then we will bring the expertise in the areas where we're particularly useful. We don't shy away from controversial issues, but like most university entities, we can't do advocacy. And so we try to walk a line there of providing useful information, unbiased science to anyone who's asking for it. Okay, that's the background on the RBC. If you have questions at the end about that, we can talk about it more. Okay. One more slide on this. So some of our research themes include freshwater biodiversity of the Southeast. That's probably our biggest one. But lately we're doing a lot more in the space of environmental justice and equity. We've traditionally done a fair bit on urban streams. Land use policy, one of the things that we've always tried to offer is the ability to take projects that final mile to actual laws, ordinances, policies, so to implementation. These days, we're also an area of personal interest of mine, and a number of other folks are working on as well, flow ecology and management, working with various management agencies on how to meet the needs, for example, of municipal water use without drying up rivers. And then the thing I'm talking about today is our partnership with the Institute for Resilient Infrastructure Systems, IRIS, and other partners, particularly the U.S. Army Corps of Engineers, on nature-based infrastructure. So, okay, now I'm done with my background on the RBC, and we'll jump to the actual talk. So I like talking about this because it's the thing that I'm engaged in that actually makes me optimistic about the future of the world. In contrast to most of the other stuff I do, trying to figure out why we're losing fish species in the Conasauga River, things where, documenting the decline of things. This is the project where I can see there's actually the potential to change, to lead to a more sustainable society. So acknowledge my co-authors here on this. Kyle McKay is with the U.S. Army Corps of Engineers. Kyle and I head up a working group of folks who are focused on biodiversity and ecosystems as it relates to nature-based infrastructure and this broader project of connecting, of rethinking infrastructure. Charles Van Ries was a postdoc up until Monday of this week when he transferred to a research scientist position with UGA. So congratulations to Charles. He's full-time on this project. And then Brian Bledsoe is an engineer at UGA, and he heads up the Institute for Resilient Infrastructure Systems and is the overall lead on the larger project. Okay, so I'm optimistic, but we need to start with some realism here. What we're doing now for biodiversity conservation isn't working. Every 10 years we set these ambitious targets. Every 10 years we fail to meet them and say, next time we're going to do it better. And our approach is unfortunately fundamentally the same, and we're not bending the curve of species extinctions and biodiversity loss. And even if it's not extinctions, we're seeing a lot of ecological extinctions. Species abundance is driven to levels where they're not performing their ecological role. Overall, just abundances and biomass of wild organisms at much lower levels than they once were. It's estimated that we're underfunding biodiversity conservation by a factor of 6 or 7. Now, I'm sure there's lots of other takes on this, but everyone who looks at this issue agrees that we're not spending what we would need to on conservation to actually bend that curve and make a difference. So I think it's worth taking time to put that spending into perspective. Right now, it's estimated we're spending about $140 billion a year on conservation. We need to be spending $900 billion a year. And I would argue that's not happening. It's not going to happen. As long as biodiversity conservation has to compete against every other societal need, human health, basic infrastructure, food, right? Where is that additional funding going to come from? It's going to be very hard to justify a massive increase that would be necessary if biodiversity conservation is competing against everything else. But look at what we're spending on some of these other things, and in particular, infrastructure, which we're focused on today. $2.7 trillion estimated per year, and that's low because that's what we've been spending, and right now this is ramping up globally. The US alone passed $1 trillion infrastructure spending act. China's Belt and Road Initiative is pouring over a decade an estimated $3 trillion, I think, into infrastructure spending. There is a lot going into infrastructure these days. Historically, that's been a bad thing for biodiversity. We can trace a lot of our biodiversity losses to civil infrastructure. One of the best examples of that is the Coosa River. And it really rivers in the whole Southeast, the Alabama system and the Tennessee system. Some of the most biodiverse river systems in the world that we've turned into a series of dams and caused the extinction of, 24 at least species of snails alone. So when we talk about infrastructure in the past, it's been something that is contributing to the need to spend more for conservation. So our proposition is, what if it what if we change that? What if we could make the infrastructure spending a net benefit for biodiversity rather than a net negative? And that's what we're trying to explore in this project. What's the potential there? If we fundamentally rethink the purposes of infrastructure to take a broader view of what we're trying to do with it, it's not crazy to think, that's what, my starting point here to convince you it's not crazy to think about this, to consider this. So that's our proposition, that we're never going to get there by trying to fund it on its own. But if we start to harness the spending that we're doing in other areas, particularly civil infrastructure, there is the opportunity to get close to where we need to be. One reason we think that there's an opportunity now is there's been, in some senses, a convergence of how we approach both biodiversity conservation and infrastructure. This is from a great paper by Georgina Mace, in which she charted the evolution of different kinds of approaches there are to biodiversity conservation historically, from the focus on the fortress model of nature, protecting nature for itself, to protecting nature from the ravages of humanity, to the focus on ecosystem services, nature for people, and then more recently, a more holistic view that's becoming increasingly common of people and nature, thinking about both together. And all four of these are still operational in conservation, right? I mean, it's not like we've made a switch, but we've added on progressively to our thinking about it that conservation needs to be done in concert with thinking about human needs as well. And that's how it's going to actually be successful long term. My colleague Kyle McKay argues that there's been a parallel evolution in civil infrastructure, from a paradigm of control of nature to moving to a mitigation hierarchy where, okay, we're going to still do the control of nature thing, but now we're going to at least spend some money trying to mitigate for the worst effects of it, to multi-purpose projects where, okay, we can do projects that can do multiple things, and then to a more recent rethinking in the last couple of decades of the whole fundamental approach to infrastructure, to focus to a recognition that the portfolio of infrastructure that we have may not be suitable to a changing world. And we need to be using different types of approaches, in particular the nature-based infrastructure, in order to have the resilience to change. Right now, our infrastructure needs are not met with what we have. We've got aging infrastructure in the developed world, which increasingly appears to be brittle, not readily adaptable to a changing climate. When it fails catastrophically. And it may not be and it may not meet shifting societal needs. But this does give us an opportunity. The reinvestment in infrastructure, the rebuilding of the infrastructure in the developed world presents an opportunity to do it differently, and in some cases remove some of the worst of the facilities that are causing harm and replace them with something that might be better. So the argument is that we've got these two fields converging together, and can we start to think about a continuum of natural and conventional infrastructure that can provide both meet our needs. I mean, there's going to be a whole range of what's kinds of projects that will be done. You know, there's going to be things that are just pure infrastructure, pure called gray infrastructure out there, and then things that are pure conservation on the other side of the spectrum. But there's also going to be a lot of work in between, and that work is already happening. So here's one of our key messages. Time to stop thinking about these things as entirely distinct things, and time to really focus on opportunities for meeting needs together. And that's partly on recognition that big projects, at least, tend to affect multiple outcomes, whether we're planning for it or not. And a great example of a big project is what's happening in Jamaica Bay. So a decade ago, Hurricane Sandy hit New York City, surrounding areas, caused widespread devastation. The reaction to that was, we're going to need to better protect this metropolitan area in the future from future events that might have storm surges, flooding. And so one of the proposals that came from the U.S. Army Corps of Engineers was a giant storm surge barrier, or a series of barriers that would cut across the entrance to the harbor here in New York City. Big things that could actually be raised to block flow of water into the bay. The general reaction to this was, that's nuts. That's going to be extraordinarily expensive. It may or may not work. We don't, how can we even begin to think about what that's going to do to circulation of water, what that's going to do to ecosystem in the nearshore area? Even Donald Trump, who likes big, bold things, said, this doesn't make sense. This is a terrible idea. So that was shelved. And instead, what the Corps of Engineers has been doing with partners is nature-based solutions. Taking dredge spoil, building islands in places where it can absorb some, the idea would be to absorb some of the impact of hurricanes. Building living shorelines instead of armored bulkheads. Using natural infrastructure in concert with traditional infrastructure. And it's going on in a big way. We don't know how well it will actually work when we have the next big event, so that will be a huge test. But it's been very well embraced by not just the Corps of Engineers, but a lot of other partners. And one of the things that excites people is the opportunity for biodiversity and ecosystem benefits in conjunction with it. So that's my main argument, point I want to make there is this is happening. We're seeing this shift underway at an entity as traditional as the U.S. Army Corps of Engineers. It's happening first and foremost in the research arm, ERDIC, but it's gradually being pushed out to the districts, which are the folks who build the stuff, at least a lot of it. And there's something of a substantial change that is being realized. So I talked about nature-based infrastructure, didn't really explain what I meant by that. We use the term natural infrastructure, nature-based infrastructure to kind of refer to a wide range of things. Everything except the conventional gray infrastructure over here. Hybrid infrastructure is a mix of nature-based and conventional gray infrastructure. Nature-based infrastructure encompasses lots of different types of things. These are from, I think it's Chongqing in China, the illustrating, they call the sponge cities concept. Managing the stormwater, giving the stormwater a place to go rather than just trying to shunt it downstream as was traditionally done. They experienced flooding in a number of cities that made them realize that the old approach wasn't working. And so a fairly radical expansion of the use of nature-based infrastructure for giving floodwaters a place to go and, in some cases at least, getting some biodiversity conservation benefits as well. This is called the, I'm going to mispronounce it, the polders of Kriebeke in Belgium. So this is former agricultural land that was actually reclaimed originally from the sea. That's now being converted to areas for floodplain, areas to absorb floodwaters in the near estuary area, which then is also being explored as opportunities for ecosystem restoration. We're also getting some traction with the idea that natural systems themselves are infrastructure as valid as human-built infrastructure. Initially, this was kind of viewed as like a metaphor, but in recent conversations I've had with engineers at the Corps, I had at least one case where I saw that aha moment where the engineer said, wait, I see it. In the same way that a coastal marsh, we can view that as providing a service, the same as we might with a storm barrier. That marsh in its natural state is infrastructure. A free-flowing river can also be infrastructure because it's providing services. And in some cases, if we can value those things properly, we can make a decision. Do we want this river to be, is it worth more to us as a free-flowing river or as a dammed river? And that's how we should be having those conversations, and from the perspective of the services that can be provided for this, including biodiversity as a service. So more examples of nature-based infrastructure you can find in these two fun books. You can get online, go to the Army Corps of Engineers website and order these. They're free. They'll send you hard copies of them. You can also download PDFs of them. Nice visual illustration of this. So we're getting examples of this, and yet there's still a ton we don't know. And there's the risk that we're going to be going into constructing these nature-based features in a big way without really knowing what we're doing and kind of repeating our past mistakes of causing a whole lot of harm because we think, okay, this is the next great thing. So the question is, how can we learn quickly to be able to inform the spending that's going to be happening, particularly in the next 5 or 10 years, to make it as good as possible. So the Network for Engineering with Nature was founded 2.5 years ago for this purpose, to try to conduct the key research to bring nature-based infrastructure fully into the mainstream. It started with the Corps of Engineers in the University of Georgia, but it's rapidly expanding to include other institutions. Anyone is welcome. If you're institutionally interested in joining, we can have a conversation about that. And we need that if we're going to be able, if we're going to be successful in harnessing all the research that's being done out there that is relevant to the design of nature-based infrastructure, natural infrastructure, this rethinking of infrastructure. There's lots of amazing work that's going on out there. How do we get that into a pipeline to inform practice? And that's one thing, like, I don't know the answer to that yet. We're still just at early stages of trying to figure that out. So we've identified 4 tasks necessary for this, and I'm focused on that first one, that collecting the scientific evidence, because that's where we're at now for the most part. I'll talk about these other 2. I won't really talk about training. We're developing some new interdisciplinary master's programs at the University of Georgia. There's other programs that are out there that are spinning up elsewhere that are trying to give professionals the interdisciplinary training they need to be able to work, to have engineers working with ecologists, and in some cases with anthropologists and others to bring this into practice. But I'm not going to really talk about that today. Instead, I'm going to focus for the next 10 minutes or so on some of the work that we're doing, including some work in my lab group on that scientific evidence. We put out this paper, this just came out a month or 2 ago, on monitoring. Focused on, says Charles Van Rees, lead author on this. This is a figure from the paper. I know it's not exactly intuitive. But the message I want to show here is we realized in talking with engineers that ecologists and engineers have been talking past each other for a long time about the importance of monitoring. Ecologists are always saying, you need to be monitoring more. We're not collecting information on these things what we're building. And the engineers are saying, like, what are you talking about? We're doing the right amount of monitoring. We go out and we see what, is it doing what is initially expected? We might have other monitoring where we're going back to see, is it performing well over time? Does it need repair? And what ecologists were actually saying is, we need monitoring for learning. We need to be informing our understanding of how the world works by looking at these things that we're building. So we debated whether to call that monitoring for learning, or we settled on research and development monitoring because we thought that might actually connect more with the range of partners involved in this. And so we need to be thinking when we're building these projects, how can we, what key questions could be answered from this thing that we're building and doing. And some would be worth more than others. Some are going to be really valuable opportunities for learning, others a lot less so. So this first step is ask what can be learned from monitoring this project. And then a series of steps to kind of help think through how you would approach the design for that. But obviously this is going to cost money. We're not going to be able to just tack this on, which is the other challenge that we've had in the past, to projects without having a budget item there for it. And so that's the other challenge we're trying to figure out is, like, where does this budget come from? If we want to have this monitoring for learning across a bunch of these projects, it's not necessarily going to come from the same agency that's charged with building it. We probably need a different pool of money for those who are studying it. We haven't solved that yet, but we're at least starting to have that conversation. So I'm going to talk just about a few projects that I'm engaged with, some of the practical questions that we're asking that relates to this broader topic of rethinking infrastructure. But this is really just, these are just a few kind of random things. There are so many projects out there that, including things people in this room are working on, that are relevant to this. One thing we've been looking at is, we're far from the first person, we won't be the last person to ask this question. Can we do stream restoration that works? Can we actually achieve stated goals with stream restoration? Lots of folks in this room probably know that there's a very common method that's used for most stream restoration called natural channel design, or the Roskin method. That's designed by analogy. You look at your stream and say, what should this stream look like? And that becomes the model. And then you get out a bulldozer and you make the stream look like that. And there's very specific guidance for this, which is why agencies like it. It's become something that is easily applied. And we get this, which to us doesn't look like a particularly natural channel. But this is what's done. This is the norm. What we're looking at here is actually a mitigation bank. So under Clean Water Act, Section 404 says you shall not discharge, dredge, and fill into the waters of the United States. If you destroy a stream, you need to enhance a stream somewhere else. But usually the folks who are doing the destroying aren't also in the business of doing the enhancing, so they will buy credits from a mitigation bank, which has gone out and found a stream, usually in a rural area, former agricultural stream, that's maybe been straightened and so could benefit from some hastening of its recovery. They do restoration, and then they sell credits to those who need to buy them under Section 404. Question is, they also have to do monitoring, it turns out. If you build one of these mitigation banks, you need to send the Corps of Engineers, whatever district that you're part of, annual reports on how the fish have been recovering. Sometimes bugs as well. It depends, district to district, what they have to do. It didn't seem like anyone was looking at this report, so we decided to. Actually, this Fish and Wildlife Service asked us to do it and gave us some funding to do it because they were curious whether these things were doing any good at all for fish. And we found out, yeah, they actually do enhance fish abundances for a few years. We looked at these records from all the records we could get from the Savannah district, and we found a pretty clear increase in abundance biomass post-restoration, but the effect didn't persist. And we're pretty sure what's going on here is that when you bulldoze a stream, the first thing you do is you clear all the trees. And so you're bringing a lot more light in. We're getting more production of fish temporarily until the vegetation grows back. We're not seeing much of an effect on richness overall. There's a lot of noise in that relationship there. It might be some evidence that you get some additional fish, but they might not stay. Again, some of these might be algal grazers that might come in temporarily and then leave. So we don't have any good evidence that the restoration achieves one of the key goals that it's supposed to, based on this program of requiring biological, ecological lift in the form of enhanced fish. Now, the question is, how should we do it? We don't yet have an answer to that. I mean, my feeling is that in most rural areas, there's not a need for restoration, and the whole premise is probably misguided. These streams will recover on their own given time. If there is something going on upstream that would be causing the stream to be out of balance, we need to be taking a watershed approach to it and thinking about it from that perspective. I do think there's a role for stream restoration, or maybe stream engineering we should call it, in urban areas, where the stream has to be constrained for various reasons, and its potential to be a natural stream is probably going to be severely limited. Those are places we might want to think from the perspective of how do we design a stream that provides the functions that are most useful given those constraints. The other thing we found in looking at some of these streams, they don't actually look, in some cases, like a natural stream in that area. We've seen Piedmont streams with step pool systems designed into them. These aren't, so the native biota aren't adapted to living in the conditions that they've created in this restored stream. They've made a stream that would work for some fish from somewhere else. So they're basically novel ecosystems, and it will be interesting to see what happens in those over time. Another area we're working on is this big question of flow ecology. So if we're rethinking, rivers as infrastructure, if we're trying to take a holistic view of the services we get from rivers, we need to be able to get pretty specific about how much alteration we can do to river flows without compromising native species. This work was really motivated by conversations with managers in the Upper Flint. So the Upper Flint River in Georgia has no major impoundment on it. So it's not a regulated system. The major water use is coming from municipal water supplies, and then there's water discharges back into the system. There's something of a net interbasin transfer where more water supply, some of the supply that's taken from the Flint is actually going over to the Ocmulgee. And there's also a lot of imperviousness. The headwaters of the Flint or the Atlanta Airport, a massive area of imperviousness. But anyway, these managers are very interested in this. How can they meet the needs of their customers without screwing up the river? And so they asked us, well, tell us what we need to do. We buy into this idea of the natural flow regime. That makes sense to us, but tell us exactly how we need to change our operations to maintain that. And that was a good question. That forces us to actually understand mechanistically how does alteration in flows affect organisms with different traits. And we don't have that mechanistic understanding for most fish species or other aquatic organisms. So that's where we're going at these days. We've argued in a recent paper, just came out a couple months ago, that we need to make progress in this, we need to think in terms of mechanistic hypotheses. We need to put them out there and then we need to test them. It's not enough just to say, well, we are going to assume everything in this system is adapted to a flow regime broadly, because that doesn't tell us when we get to a point where we're going to lose one species or another. And luckily we're at that management place where we've got the opportunities potentially to do that. So now we need to figure out enough to inform it. One way I think we can make progress is by looking at time series of abundance data. We have more and more of these long records. 20 years ago there weren't so many of these, but now there's quite a few cases where we've been collecting counts of fish in the same place through time, and we can look at those counts as a function of antecedent flows and learn something about when flows of a certain kind, high or low, are knocking back those fish populations. So we're working on a series of papers we've pulled together a lot of these data sets, and we're playing around with that idea. We're also looking on the ecosystem functional side of things. This was, again, a question that came to us from the Corps of Engineers. A colleague said, y'all are always telling us we need to think about managing flows for function as well as structure. So here's a bit of money. Tell us something a little more specific than that. So we said, OK, what's a basic function? Primary production. Can we test the effects of different types of flows on primary producers? We can look at the whole river metabolism these days pretty well just by looking at the patterns of dissolved oxygen. But that doesn't tell us why it's changing, why that metabolism is moving up and down different flows. To do that, we need to have something of a mechanistic understanding of what's happening to the different players. Things like Pedostomum, this vascular plant that grows tightly attached to rocks, it's pretty resilient it actually likes to be in high flows and is pretty resilient to different changes in flows, unless the water gets low enough that it can be grazed, in which case it gets knocked back. And then if it's exposed and desiccates, it's going to have a very slow recovery time. In contrast, algae can recover a lot faster, but is affected in different ways by high flows. So we've been trying to build, student Kate Kahn has been working on trying to build these relationships, get more of a mechanistic understanding how flow affects primary production via these different players. And the last one I'll talk about is how do we decide which dams we want to keep and which ones we want to remove? We've got a lot of dams that have aged past their design lifespan. They're now hazards in many cases. And so there's motivation to remove a number of these, both small and large. But those decisions, by and large, aren't being made on the basis of looking at the balance of services and disservices provided by those dams and what the benefits, what the services and disservices in contrast could be from a free-flowing stream. So we're trying to provide a structure for that decision-making. One piece we're looking at in particular is greenhouse gas emissions from small impoundments. These have been pretty well studied in large impoundments, but we don't really have a great sense for how variable they are in small impoundments. We'd like to have predictive models of this. It would be nice if we could use, maybe aerial imagery or something to get a sense for this and just different characteristics of ponds if there were patterns. But we don't yet know enough about those patterns to be able to make any predictions to say, that pond is likely a very high methane producer. Right now, you'd have to go out and measure it in each one of these. So we're trying to increase our understanding there. And then use that and other research going on to inform multi-criteria decision frameworks for dam removal decisions. Okay, and one more thing. How do we prioritize infrastructure to maximize biodiversity and services? Right now, in the upper Midwest, there's a lot, actually elsewhere in the Midwest, there's a lot of attention on setting back levees from the river, allowing flooding in some places in order to protect infrastructure downstream primarily. Cities downstream are realizing that, Brian Bledsoe calls this pressurized depressurizing the river system. That we've built systems that tend to be high pressure. When we increase the water beyond a certain point, it's got nowhere to go but somewhere bad. So how can we design these systems in places where to give that water somewhere to go? That gives us an opportunity to reconnect floodplains. Well, there's a whole lot of things that we can think about as potential benefits from that floodplain reconnection. What about denitrification? What about biodiversity? What on earth do we even mean by biodiversity when we're talking about it in a floodplain? Is it plants? Is it fish that spawn in floodplains? Is it birds? There's a whole lot of questions we're realizing that need to be answered there. And then trying to make these things commensurable. How do you value some aspects of biodiversity versus others, and versus the cost of a project or other benefits from the project? We're not there yet. We're working with economists on this problem, trying to think it through, ecological economists who try to think about how we, different ways of valuing these types of things. But it's hard. There's a lot of work to be done there yet. Okay, real briefly, we're also doing some work to try to provide some guidance in the short term. One thing that we've done is working with landscape architects to build design libraries, visualization libraries to help guide projects in, for things where we know a fair bit about what works and what doesn't. More broadly, we're going to need at some point to rethink some of our laws that we have out there. And not just things like the Endangered Species Act, which we probably also need to think about at some point. But can we make biodiversity and also equity, which I'm kind of bringing out of the blue here, part of the core mission for infrastructure agencies? So yeah, why am I talking about equity? From the beginning of this project, the Network for Engineering with Nature project, we wanted to also see, could we use infrastructure has also been a tool to do harm in terms of environmental justice. It's been one of the fundamental ways that we've harmed a lot of communities. And therefore, it also has the potential to reduce inequities. So what if we made as a core part of the mission that what we're trying to do for projects is the equitable provisioning of services, ecosystem services or artificial services. But that equitability is baked into that, right? We're still exploring it. Could it, is it as simple as that, just putting it there? If that becomes part of the mission, I mean, if it's right now, equity for a lot of agencies is a nice to have. When you've got some additional funding, let's try to also reduce inequity with this, or let's try not to at least advance further inequities. As long as it's not part of the core mission, it's going to remain a nice to have. And that's true of biodiversity as well. If we really want to change practice, if we want to transform how we're doing infrastructure, the agencies themselves need to perceive these as something, as their business, as the thing they do. And so we're starting to explore, well, so right now, from like a municipal perspective, we were talking with folks in the city of Austin about how they do prioritize their urban stream projects. And there's nothing that would stop them from doing this on their own. Traditionally, they would say, well, we've got to meet the requirements of the Clean Water Act. That's really what drives our work. But that's actually makes a floor for them, right? You've got to do at least that. But nothing stops you from, in this space up here, once you've met that floor, from making equitable provision of services part of your decision process, or central to your decision process. But if we really want to go beyond that, then we would need changes to federal infrastructure enabling legislation. Things like Water Resources Development Act, the various Energy Acts, Surface Transportation Acts. These things go by lots of different names year to year. They could be baked into those, which would then, again, I think, transform over time the culture of the agencies that are implementing them. In the Infrastructure Investment and Jobs Act that was passed this last year, there is a requirement for a lot of these programs that equity be advanced. But this is a huge opportunity for us to advance this idea of transforming infrastructure to benefit biodiversity and equity. But it's also very scary. There's just an enormous amount of money that's going to be spent over the next 10 years. And the agencies are trying to figure out how to even unload these amounts of money. So there definitely is a possibility to do harm with it too. So we've got, I think, kind of a mission as ecologists and all those who are working on water to engage with this and try to do as much as we can to guide this in the best possible ways. The money's going to be spent one way or another. Okay, so we have this opportunity in places undergoing redevelopment like the US to have a net gain for biodiversity. That's probably not going to be possible in parts of the world where we're building a lot of primary infrastructure for the first time. We're going to still be fighting something of a rearguard action there. But there's been a number of discussions about how to make, this is showing the Belt and Road Initiative overlaid with biodiversity hotspots. There's been a number of things written arguing that there is an opportunity, even something as that's going to create as much infrastructure as Belt and Road, to put biodiversity central to it. That's at least going to minimize the harm that's done. This is the Nam Thuyen 1 hydropower project being built in Laos. I mean, there's a lot of new infrastructure that's going to be built, particularly in these southeastern Asian river systems. Okay, so this is the upshot. We've got a once-in-a-lifetime opportunity, I think, to change how our society conceives of infrastructure and biodiversity conservation. This won't be easy, and it's going to require interdisciplinary collaboration, you know, a willingness of ecologists and engineers, social scientists, others, to engage together to make the most of this opportunity. Acknowledge the rest of the Noon Biodiversity team. It's actually growing a bit beyond that, and as I said, we welcome more members of the network. And with that, I'd be happy to take questions.